All right. In the exit question that you had, it looked really good in the room of making an inequality out of this situation. So we have 89 people have tickets for the school play. How many more people can attend? How many more people can attend if the school auditorium has 300 seats? So the inequality that we're going to use that most of you chose was this 89 plus P has to be less than or equal to 300 because there are 300 seats. And some of you took it a step further and you subtracted 89 and you got P to be less than or equal to 211, which works also. So the number of people that can come to the school play have to be less than or equal to 211 because there are only 300 seats in the school auditorium. Okay, the next step that we're going to take it today is with those inequalities, we're going to look at what happens when we multiply or divide. So if we have something like, let's not even look at anything with a variable. Let's just look at something really simple such as 2 is less than 5. So what we've done so far, this inequality right now, 2 is less than 5. Is that true? Yeah, that's true. 2 is less than 5. Now, what if we add 3 to both sides? Will it still be true? Let's see. 2 plus 3 is 5, and then 5 plus 3 is 8. Is that true? Is 5 less than 8 after we added 3 to both sides? Yes. Okay, so when we add a certain number to both sides, it still works. It still remains true. Let's see if we subtract. See if it remains true. So let's subtract 3. Will this inequality still be true? 2 minus 3 is negative 1. 5 minus 3 is 2. Is negative 1 less than 2? Yes! It's still true! Luckily, because that rhymes also. Okay, so now let's check with multiplying. If I multiply 2 by 4, and I do the same thing over here, will it remain true? 8, this will become 20. Is 8 less than 20? Heck yeah! What if I multiply, okay, we've done multiplication. Let's check with division. Divide by, oh great, I chose numbers that aren't going to divide into anything other than 1. Let's just go with 2. Hope for the best. 2 divided by 2 is 1, and 5 divided by 2 is 2.5. Is the inequality still true? Yes! So it works. But now here's the strange part. If I bring in negative numbers, okay, let's try some negative numbers. If I multiply by a negative number, such as negative 2, what's going to happen? So 2 is less than 5. That's true. If I multiply by negative 2, it becomes negative 4, and this becomes negative 10. Is negative 4 less than negative 10? No. Does not work. It turns the inequality to be not true. Oh, weird. Okay, let's see if we divide by a negative number. Divide by negative 2. So 2 divided by negative 2 is negative 1. And 5 divided by negative 2 is negative 2.5. Is negative 1 less than negative 2.5? No! No, 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 no. So, that is where the property comes in about when we have an inequality and we're solving it and we add a number to both sides, the inequality is going to remain true. If we subtract a number to both sides, the inequality is still going to remain true. If we multiply or divide by a positive number, still going to be fine. Still going to be just fine. It's only when you multiply or divide by a negative number that you need to then rethink the situation. Okay? So let's try one here, and you'll see what I mean. So let's say we have the inequality negative 3 times y is less than or equal to 12. Very simple. And it just says to go ahead and solve the inequality. So in order to solve it, I'm going to have to undo the multiplication by -3. So I'm going to divide using the division property of equality. Divide by -3. But right there, a bell should be going off in your brain saying, oh my gosh, 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 I'm dividing by a negative number. What is then going to happen to the truth value of this inequality? Because now we have a variable and we're not going to be able to tell. So what happens is it ends up being false. So meaning I'm going to have to change this inequality around to make it true. So if I take -3y and divide by -3, I'll get y. And 12 divided by -3 is -4. But this less than or equal to is not going to be true anymore. It's not going to be true. So remember, we just tested it and it wasn't true. If you don't believe me, we could graph the solutions, put -4 on the number line because that's my special number. I'm going to go 1 up, 1 down. I'm going to use a closed dot, -4. And then values that are less than -4 are over here to the left. But if I check my work and I plug in at least 2 things to make sure we're good, and I plug it into the original, and I plug in -5 here, -3 times -5 would be 15. And is 15 less than or equal to 12? No. So the values that I pick are not true, meaning that I'm going to have to flip this inequality around to keep it true. So I'm now going to say that the solutions are not less than or equal to -4. They're going to be greater because I divided by that negative number. To make the inequality not true, I need to flip it around. So now if I go back and I recheck my work, and I recheck and I plug in a value that's greater than -4, like -3. -3 times -3. Is that less than or equal to 12? So -3 times -3 is 9. And that is less than or equal to 12. It works. If I plug in something else, like 0, because 0 would be on this side of -4. 0 is greater than -4. If I check it and I plug it in, -3 times 0 is 0. And is 0 less than or equal to 12? Yes. Okay? All right, one more to try with me. Let's say we have m divided by -2 is less than 1. So to solve this thing, I'm going to have to get rid of the division by -2. So to do that, I'm going to use the multiplication property of equality and multiply it by negative, ding, 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 ding. I'm multiplying by a negative number. So when I multiply by a negative number, it's going to make this inequality not true anymore. Meaning, when I'm solving, I'm going to need to flip it. I'll end up with m is not less than, but it is greater than -2. So now when I graph it, I'll have -2, 1 up from that is -1, 1 less is -3. My open dot, because it can't equal -2. And then it looks like I shade in values that are greater, so to the right. And if I check my work, so now I'm going to erase my solution, I'm going to go back to the original, and if I check my work and I check like -1, -1 divided by -2 is what? Positive, because they're both negative, it's going to be positive 0.5 is less than 1. Is 0.5 less than 1? Yes. Let's pick a different value, a nicer value to plug in than -1. Like, how about 2? 2 exists over here. So 2 divided by -2, and we're wondering, is that less than 1? These are different signs, so it's going to be negative, and 2 divided by 2 is 1. And is -1 less than 1? Yes! Okay? So tomorrow, I'll be looking for bells going off in your brain, people, of when what is happening. When we are multiplying or dividing by a negative number, because that inequality is not going to be true anymore. So you're going to have to think about it, and bells, bells, bells going off.